Okay, the last part that I'm going to cover on the videos has to do with nuclear fusion. If you look in Mooney's, they have one more example at the very, very end. But this is the last part I want to cover in terms of theory. We got a little thunder and lightning going on outside there. Anyhow, nuclear fusion. Again, when two light nuclei fuse together, such as in the sun or in a fusion reaction, and we also have H-bombs, fusion, those are fusion bombs. Remember that once they get together, there's less energy due to binding energy once they're together than when they're individual. And where does that energy go? It's given out. There's a tremendous amount of energy involved here. There's way more energy per nucleon in a fusion reaction than in a fission reaction. Nuclear fusion has much more energy is released than in this type of reaction. Anyhow, I've used as an example the proton-proton cycle that occurs in the sun. I'm not giving the whole thing. I'm just going to give you part of it. So in the sun, you've got hydrogen. Again, this is protium, hydrogen 1, combining with another atom of hydrogen 1. And they're going to fuse together to give you hydrogen 2. All right? Sometimes you'll see if you look in the textbook where this is in there, they use a D sometimes for deuterium. Ooh, lightning flash. And when that happens, wow, that's close. I don't know if you could just hear that, like thunder. And what's given off also is a positron and a photon in the gamma ray end, so highly radioactive. Highly radioactive. Lots of energy here. Now, next step. You have protium isotope reacting with the deuterium isotope that we just produced. Again, this is fusion. To form an isotope of helium. Helium in its most stable form is helium-4, but this forms helium-3. And when that happens, it also gives off a gamma ray photon, okay, gamma photon. And then the next possibility, and there are actually a couple of possibilities, I'm just going to give you one of them. There are a couple of things that could happen here. You could have helium-3 combining with another helium-3 to give you helium-4. I'm just going to give you the one possibility, one other possibility, which is where protium combines with that helium-3 to give you helium-4 plus another positron. Anti-electron is a positron, an electron with positive charge, a positron. No mass, essentially, positive charge, plus a neutrino. Okay? And in all these things, energy is given off because the mass of the reactants is greater than the mass of the products, or rephrase that, the mass of the products is less than the mass of the reactants. And where does that go? This ends up with plus energy. Frequently they talk about the Q value, which is the energy related with these. These go off with a lot of kinetic energy. These things have gained, so where does that energy go? That's actually, I'm really glad I just thought to mention that. How does that energy show up? Okay, you say there's a lot of energy given off, but in what form? I mean, we're already talking about subatomic particles here, so how does it appear? Well, these things all have energy, and this has energy, and they're all flying apart, and they all have kinetic energy. They have kinetic energy, the kinetic energy is carried off. So they have less mass than the reactants, but they have more kinetic energy. All right, they gain kinetic energy. That's how that shows up. Okay. I hope you're having a lovely spring break. If this is something I gave to you over spring break. Anyhow. Goodbye. By the way, you're all good people.